which can be easily understood by the human as well as by the computer, a common language for both the human as well as computer. So what happens here? Our natural language code is, we are converting this natural language into a programming language. So we write we write some instruction in the programming language. So our natural language is converted to programming language. We are converting it. Nobody externally is converting. We are converting it. Okay. So we are writing instruction in a particular programming language. We have several programming languages that we will see later, but we choose some programming language and we write all the instruction and we provide the data in the programming language. And those programming language instruction will be later converted to the machine code, and then only it will be sent for execution. It is not directly fed inside the CPU. It is converted to a machine code and then only it is sent for execution. Who is doing this conversion? We can generally term it as translation. Who is translating programming language into machine language? Compiler or interpreter. Here comes a new two terminologies called as compiler and interpreter. So we will see about the compiler and interpreter later. But any programming language have to be converted to machine code and it has to be translated, and this translation will be carried out by either a compiler or an interpreter. Okay, so we will see about compiler and interpreter later, but now I'll stop here and I'll tell you that we have several languages like programming languages, natural languages, machine languages. We have several languages. I need to classify these languages into two categories. One language is called as low level language. One language is low level language. What is low level language? All the languages which are understood by the machine. All the languages that are understood by the machine are called as low level languages. For example, there are two kinds of languages that machine understand. One is machine language, directly ones, zeros and ones, machine language. What is the next thing? The next thing is, one is machine language, and what is the next thing is? Next thing is assembly language. I hope everybody know what is assembly language. What is the assembly language? Assembly language is a language that is directly connected to your hardware, and using assembly language only program language was created. See, assembly language is also not directly understood by the computer. It also has to be converted to a machine language, then only it will be the computer will understood. But assembly language is a raw kind of language using which we have developed many programming language. Now, so low level language means machine understanding languages, machine language and assembly language. Coming to the next category, it is high level language. What is high level language? High level languages are the programming languages which is understood by the humans. So for example, we can take C, then let me take for example, let me take C++, CPP, C++, and let me take Java for example, and let me take Python, and let me take C#, and for example let me take VB, and we will take VC++. So for example, so low level languages are the languages which is understood by the machine, and high level languages are programming languages which are understood by human, as well as it is understood directly by the humans. So these high level languages can be categorized. They can be categorized into three. What are they? One is compiler based high level language. So compiler based. What is the next one? Next one is interpreter based. What is the next classification? Next classification is a hybrid high level language. So now we will see what is the difference between compiler based, interpreter based and hybrid based high level languages. But before that, we will first of all come to a conclusion. What is the work of compiler? What is the work of interpreter? And we will see that. Then we will come to the difference between compiler based languages, interpreter based languages and hybrid based languages. And coming to compiler based language, I C is a one big example. C and C++ are one big example for a compiler based language. For example, to make you understand, let me show you some C language code, and you need not to understand the code what is written here, but let me show you some C language code and what a compiler will do. So for example, if you see this, what is this actually? This is a data file. This is a data file. Why I call this is a data file? Because Visual Studio is like Visual Studio.exe. It is a program file, and whatever you create inside this program file .c, I told you .exe is only program file. All the other files are data file. So this is not .exe. So definitely this is a data file. A data file cannot be directly taken to the CPU and cannot be directly executed. So for that, what you need to do, first of all, you have to convert this natural language. You have to convert this data file into a machine language. How will you convert it to a machine language? You have to do translation. How will you translate that? I told you, using compiler. So what you do is that for this corresponding line, there will be a corresponding translating line for the machine code. So what you do is that you check this line whether if there's any error or not. If there is no error, convert it into a machine code. So first of all, you check for errors. If error is not there, what you will do, you will convert it to a, if there is no error, then you convert it into a machine code. So this line. So for every line this is performed. This checking error and converting to a machine code is happening. So check error, and I just move to every line. I do this process for every line. So for every line to up to last line. So when I do it to up to the last line, when it is finished, if there is no error in between, if there is no error in any of these lines, and what finally will happen is that finally executable file will be created. It means that a .exe file will be created. What that exe file will be having? That exe file will be having all the machine code. Each and every line is converted to a particular machine code, right? That machine code cluster of all the line machine code, all the machine code will be stored in that particular .exe. For example, I will show you. Just I will execute this program and I will show you. For example, I will be executing this GCC. And what I have to do, I'm going to do a translation, right? Translation from a file, from a data file to a program file. So you need to mention what is the name of the program file you are going to generate. I'm going to generate it like hello. Hello is the name of the output file, which I say. What is the output file? It is a program file. So name of the program file is hello, followed by what is the file that you need to translate. Binary search.c is the file, data file I need to translate. So when I give this line, what happens is all these lines are executed. So each and every line is converted to a machine code, and since there is no error, is shown. So what will happen? The entire lines, all these lines are converted to machine code, and this machine code is clusterly stored in, for example, I'll show you in the desktop in a particular folder. I'm having that file. Okay, I'll go to data structures, arrays, and I have, you see binary search.c is here, source file. You can see source file and type application. So this is hello what we created. So if I go and see the properties, the type of file, it is .exe file. So what happens actually, can you able to understand? You have a source code, you have a natural language, you have a data file, and this data file cannot be directly executed because your machine does not understand this natural language. So you have to translate it. How you have to going to translate? Using the compiler. What your compiler do? It checks for the error of every line, and if there is no error, it is converting into a machine code, and that machine code is clusterly stored as a .exe file. Now .exe file means it is a executable file. It is a program file. Program file means it is having only zeros and ones. So now the program files are understandable by the computer, and directly you can send this .exe file to the compiler, so to the CPU. So in the first slide itself, I have shown you. Now your program file is created in the hard disk, which is hello.exe here in the folder. If you see hello.exe, and this program file can be sent to your main memory directly, and hereafter it can be executed. Fine. So now let me come back again here. So if you see here, C is one of the compiler based language I told you. So what is a compiler? What is the usage of the compiler that we have seen so far? What does compiler does? A compiler will check for error first of all. It will check for error. If there is no error, okay, if there is no error, then what will happen? Then each and every line, okay, each and every line will be converted into machine code. This is what your compiler will do. Okay, if there is no error, okay, fine. If there is error, what will happen? That also we need to know, right? If there is error, if there occurs error, what has to happen? For example, I'll show you here. Suppose if binary.c, if there is any error here, for example, the error might be here. What is the error? I can just take the semicolon. If I take the semicolon, it is like error. We will see why that semicolon is given. That all we'll see later. But if the semicolon is not provided, it is considered as an error. When error is made, what will happen? What compiler will do is that it will check up to this line. No error is there. But since error is found at this line, no executable file can be created. Why no executable file can be created? Because executable file is a collection of machine code of the entire source code. For the entire source code only, executable file have to be created. Since there is error in this line, you cannot proceed with the executable file because you don't have the machine code. You have the machine code of every lines. You have the machine code of the partial lines only. So when error is occurring either in the first line or even in the last line, what will happen? Your compiler will not create any file. Your compiler will not create any program file. So if error is found at any line, if there occurs any error, what will happen? Then no executable file will be created. No executable file will be created. So what we can say further, no executable file means no program file. So when there is no program file created, what cannot happen? Execution cannot happen, because this program file only we need to send it to CPU for execution. But when no program file is created, what cannot happen? Execution cannot happen. So no execution if error is happening. No execution can happen if error occurs. So I think that's very clear. Now let me show you one more thing. But even though the error is occurring here in this line, error is occurring here. For example, I'll just save this document. Again, let me just compile this after making a syntax error. I'll just again now it is showing a compilation error. Since the compilation error is done, no file will be created. But if you go and see the folder, still the last created hello.exe is still here. So what you can say is that only one time translating is enough. Translate the given file to a program file for only one time, and that executable file will remain saved forever. So you can use this translated file anytime. You no need to translate again. Only one time translating is enough. So you can say the next feature is that, what is the next feature? Next feature is that for the compiler, only translating one time is enough. Okay, translating one time is enough. Fine. Now we will come to interpreter. You know what is compiler. Now we will come to interpreter and we will see the differences. And one important language which comes under interpreter based language is Python. So Python is a interpreter based language. You need not to know what is Python, how Python is written, but we will take a simple program of, not a simple program, a program of Python. And now using this, what I need to tell you is that we will compare each and every line here. Check for error. Yes, this also will check for error. Each and every line will be checked for error. If there is no error, for example, here this line, I will be checking for error. Okay. Here, I will just check for error, and if error is not found, if error is not found, what I will do is that I will just translate it. Okay, I will just translate to a machine code, and simultaneously I will translate and simultaneously execute it. I will simultaneously execute it here itself. So it is very clearly, you can able to see the difference. I check for error for every line, and if there is no error, it is translated. Once it is translated, it is simultaneously executed there itself. So if it is executed in the time of translation itself, then no execution file is created. There is no need of any program file here. There's no need of any program file. So for the first point that you should remember is, you are going to check for error, and if there is no error, found, then each and every line will be translated. For example, it will be translated and executed simultaneously. So because of this translation and execution happening at simultaneous time, what will not happen? Executable files will not be created. Executable files will not be created. So it means that there is no program file for interpreter based languages. So if you come here, there are no program file for an interpreter based language. So now what will happen is that execution will happen, and here you cannot say that translating is going to be only one time. No, because since no program file is created here, what cannot happen? Every time when you want to execute, every time you have to perform a translation, because no program file, the translated code are not saved anywhere. So one time translation is not possible. So one time translation is not possible. And now, since program file is created here, the program file is sent to the program file is sent to the main memory and is executed. What is main memory? RAM. I told you, when the program is closed, then it is in hard disk. When it is open, then it comes to RAM. When it is open means when it is in execution state, it comes to RAM. So when it is a program file, then I can take it to the main memory and I can execute it. But there is no program file here in the interpreter. Since there is no program file here in the interpreter, what cannot happen? The execution is not happening in the CPU. Then where it is happening? It is taken care by the CPU, but it's not directly executed by the CPU. It is indirectly executed, but the execution is happening inside the interpreter. Here program file is created. So since program file is created, I'm sending the program file to the CPU for execution. Here no program file is created, so I cannot send any file for execution to CPU, but instead of that, what I'm doing is, inside the interpreter itself I'm executing. So here execution is happening outside the compiler. Here execution is taking place inside the interpreter. So this is taken care directly by CPU. This is taken care, interpreter is taken care indirectly by CPU. So interpreter based languages are slow languages because it is not taken care by the CPU directly. So interpreter based languages are slow languages, compiler based languages are fast languages. So C++ are called as fast languages, and Python, Ruby languages are interpreter based languages, which are called as slow languages. And now here comes a game, like now it comes to hybrid. What is hybrid? Hybrid means it uses both interpreter as well as compiler. It uses both interpreter as well as compiler. Any example for it? Yes, Java is one best example for a hybrid language. So Java is one better example for a hybrid language. So Java is very powerful language because it uses the feature of both compiler as well as interpreter. Right? I think by this illustration, it is very clear to know the difference between a compiler based programming languages and interpreter based programming languages, and what is the usage of compiler, what is the work of compiler? Translation. What is the work of interpreter? Translation. But these translations are happening in a very different manner in compiler and different manner in interpreter. Okay, so now we have seen how this is how compiler and interpreter is working, and now we will come to something called as operating system. Very important part. What is the operating system? What is operating system? Operating system is also a program file. Operating system is also a program file. For example, if you come here, operating system is also a program file which is stored in the hard disk, but it is a master program file. What is a master program file? This program file, this operating system will be there in the RAM. Once you switch on your system, automatically your, for example, if you have Windows, what happens? What are the common operating systems we have? The common operating systems we have is Windows, and we have Linux, and we have Mac OS X. Okay, so these are all common operating systems that people use, and these are the common operating system that people use. And operating system is a master program that manages all the resources. Okay, it is a master program that uses all the resources of the computer system, CPU, hardware resources of the CPU, to provide services. What services? It is this master program called OS will only give instruction to the CPU to execute all the other program files. For example, we are inside operating system. Inside the operating system only, if you see, inside the operating system only calculator is there. Inside the operating system only notepad. Inside the operating system only we have the browser. So all these program files are inside a master program, like called as operating system. So if I want to ask my CPU to execute a particular program file, for example, if I want to ask my CPU to execute a Firefox program file, then my operating system, which is a master program file, which need to request my CPU to execute this program file. So operating system is a master program file that manages all the other program files. So it is a manager. So operating system is a manager. Fine. So this is what you need to understand about your operating system. That's a basic thing about operating system, right? So I think what we started with the session is that we started with the agenda of knowing how a computer work. I think we know now how a computer work. What is ALU? What is control unit? What is input and what is output? What is main memory? What is RAM? What is hard disk? So you know all these things. And coming to number system, you know what is the number system available, what is called as base, you know what is binary, and you know what is decimal, and you know the conversion of binary and decimal, vice versa. And you know what is a program also. I told you an example also for what is a program. Then a difference between a low level and high level languages. Then we came to compiler versus interpreter, and finally we ended up with operating system. I think the agenda is very clear, and also it is very clearly evident that we have finished the agenda to the code. So all these things you should be very clear enough in order to learn any programming language, not only C. If you know all these things only, you know what happens while you are compiling, what happens when you are interpreting something, what happens when you execute something. Then only you will be able to understand the behavior of any programming language better. Okay, so in the next session what we will be doing is that we will be learning about something called as programming paradigms. What is programming paradigm? Means style of coding. We will see few styles of coding that is very important before we start to learn about any programming language. Okay, so we will see about programming paradigm in the next lecture, and we will continue to the first program. We will start with the basics, and we will enter into data types, and we will move forward. Okay, so we are going to do everything in a slow manner because we need to be very clear in whatever we are going to do. Okay, so hope it is very clear, and if there is any doubt, and this video is available in the our channel, and first of all what you do is that you just subscribe to our channel and follow the channel. We keep on creating a lot of live sessions useful for the students. And one important thing is that And one more important information is that you can go to the link called myslate.sixphrase.com, and in this link myslate.sixphrase.com, okay, in this link there is n number of courses available, like Python programming, Java, data structure, C programming, LNT test series, TCS Ninja, and we have programming languages, data structures, algorithms, as well as we also have company specific problem sets also, courses. So this is all industry oriented questions are there. So what you can do is that if you want to purchase this, let us know through the comment section and we'll help you in purchasing these courses. And anybody who want to purchase this course can just give a comment if there is any problem in purchasing it, and we'll be helping you at the back end. Okay, so all these courses are very useful, guys, and I will recommend you to purchase these courses one after the other and complete a course and then go to the next course. Okay, so when you just finish all these courses, then you will definitely be able, you will be ready, you'll be ready to be entering into, you will be ready to crack any company specific company. So if you take these courses and if you take the best of these courses, and then I can assure you that you can enter into any organization with ease. You can enter into any organization with ease. So thank you, guys, and this is it for the session, and we will meet in the next session. Thank you.